Hi, this is Dr. John Bergduff. In this video, we're going to explore this wonderful tool of using base 10 blocks and show how we can use them to illustrate addition of whole numbers. So if you remember from before, the base 10 blocks includes units, which represent single ones, and longs, which represent groups of 10. You'll notice that each long consists of 10, essentially looks like 10 units stuck together. So what I have illustrated over here on the right is exactly the number 57, which is 5 longs and 7 units, and 35, which is 3 longs and 5 units. I'm going to illustrate how to add them by simply putting all the blocks together. While I'm doing that, though, I'm going to make myself a little chart over here to keep track of how many of each I have. And the chart will be important because it will essentially lead us to the standard algorithm for addition of whole numbers. So over here in my chart, I'm just going to keep track of how many longs I have and how many units I have in each of these numbers. I have, first of all, 5 longs and 7 units. And then for the second number, 3 longs and 5 units. I'm going to put a line and create one more space where I'm going to look and see what happens when I put them together. So thinking of addition as putting together, I'm first going to take all my units and put them together, just move them all together. If I count, that's going to create 12 units. And the beauty of the base 10 system is whenever you have 10 of anything, you put them together for the next higher place value. So I'm going to take and count out 10 of these units. And what you should actually do is let your students, if you're a teacher, show and observe that those 10 units really are the same as a long. So I trade out or exchange the 10 of the units I had for an extra long. Still have 2 units left, but I've got an extra long, and I'm going to put this over here with the other longs just kind of up there out of the way. Let's write down what we just did essentially in our chart. When I took my 7 units and my 5 units, I ended up with 12 units. I leave 2 of them as units, but I take 10 of the units, create an extra long, and much like I put the long up here with the other longs, I'm just going to keep track of it in this column over here. So now I have 1 long, 5 longs, 3 longs, and I put all of those together. That does include that one that I exchanged over. And I will end up with a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 longs, and let your students simply just count that. Now, what I have both in my chart and over here on the table in the blocks is simply the number 92. And if you look at what we did, if I take away the structure of the table, you'll realize that I have simply employed the standard algorithm for adding 2 whole numbers. I said that 7 plus 5 is 12. But instead of writing a 12 down here, I leave the 2 in the ones place and exchange 10 of the ones for an extra 10, which is like an extra long. And then I combine all the longs, 5, 8, 9. And so my base 10 blocks are exactly illustrating the standard addition algorithm. Let's do another one, however, where the numbers are just a little bit bigger, just to show that this carries over, no problem. We're going to look at the number 739 plus 739 plus 363. Let me take a moment to set up these 2 numbers in base 10 blocks. So my first number on the top, needs 9 units. Let me count out 9 units here. 1, 2, 3, 4, 5, 6, 7, 8, 9. I can see the 9 units real plainly. And my second number is going to need 3 units, so I'll keep that together. Let me kind of make some space. This number represents numbers of longs. So the first number, which I'll put on top, requires 3 longs, and the number below that requires 6. I believe that's exactly what I have right now. But then I need a larger unit. I need flats. So the top number needs 7 flats, 1, 2, 3, 4, 5, 6, 7. Let me count them out as I put them down. 1, 2, 3, 4, 5, 6, 7. So I'm just being very careful to count them accurately. And the other number, the lower number, needs 3 of those. 1, 2, 3. So I have exactly illustrated the numbers here: 739, 363. But let's make them into a chart. This time I'm going to need an extra column for flats, and I'll still need my longs, and I'll need my units. And I'm actually going to leave a little bit of space to the left because I think I'm going to need more than this. First number, 7 flats, 3 longs, 9 units. Second number, 3 flats, 6 longs, 3 units. We will practice putting these together, which is the idea of addition. So let's do that and make whatever exchanges or trades that we can. So I take my 9 units and put them with my 3 units, and now I've got 12 units. So lining these up, it should be the case that I should be able to trade out 10 of them. I believe that's 10, but we can know that by lining that up with a long and observing, yes, that creates a long. So I've got the 2 units, and I've created a long by an exchange. The way I'll write that in my chart is that I've got 2 units here, and I've created an extra long, which I'll just kind of put up here among the other longs and include it with my set of longs just like that. Now I'll combine all my longs. So I have 1, 2, 3, 4. I'm going to lose these for just a second to bring them right back. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have been able to create 10 longs. Okay, now I can bring these back, I think. Let me put them down here, just we don't want to lose them. Those 10 longs can be exchanged for another flat. So I take this flat and put it among the other flats, and those 10 longs go away. Here are my 2 units. Now there are no longs left, but I do have an extra flat. Let's see what that looks like in my chart. I had 1 long, 3 long, and 6 longs. That made 10 longs, but I exchange all of them for an extra flat, leaving me with no longs at all. And then I've got my 1 flat that I created by an exchange, the 7 flats from the top number, the 3 flats from the bottom number. I put all those together, and that will create 11 flats. But anytime you have 10 of anything, you can exchange it for the next larger object, which would be a cube. I can line these up and observe that the 11 flats can be exchanged, 10 of the flats can be exchanged into a cube, leaving me with 1 flat only. So I have a cube, a flat, no longs, and a unit. Let's see how this looks in my chart. 7 flats, 3 flats, 1 more flat, that's 11 flats. That's leaving me with 1 flat. And I'm going to need to exchange those flats for a cube using the language that most people are familiar with. We're carrying or exchanging, which is a word that works better with the manipulatives. So we have 1 cube, 1 flat, no longs, 2 units. That is exactly an illustration of the number 1102. And as you can see, what we have done is essentially created the standard algorithm for adding 2 numbers. 9 plus 3 is 12. leaves 2 in the ones place and carries a 1 into the longs place or tens. 6 plus 3 plus 1 is 10, leaving me nothing in the tens place or longs place, but creating something new for the hundreds place or flats place. 1 plus 7 is 8, plus 3 is 11, leaving me 1 flat and creating, oh, this one wasn't here before, creating the extra 1 that becomes the cube or the thousands place, and I get 1,102. And that's a great illustration of how base 10 blocks can be used to illustrate addition.